A very good morning to Nanda. Last class, last two lessons we have seen about the types of what I defined. I have defined what is it messenger and what are the types and what are the application I have defined. Correct. Followed by that, I have told you a main important theme called the types of flow. That is parallel flow, counter flow, and cross flow. I have shown. Okay, and I given examples also. And followed by that, we have discussed an important topic called the overall heat transfer coefficient. Okay, it's very important in case of heat exchanger problems because either you have to estimate U or you have to estimate surface area of heat exchanger or you have to find the outlet temperature of the cold fluid or hot fluid or the either the heat transfer because all the Q is equal to UA del T. Okay, that's a major thing you have to remember. Okay, and if I want you to remember this most important formula how to find this u. Okay, it's very important. I just give you a easy thing that you don't worry, just put 1 by ua. Okay, 1 by ua is equal to what is equal to r total. Okay, this you must remember. Okay, so see 1 by is equal to 1 by u is equal to r, so 1 by u is equal to r total. Correct. This is just add all the resistance in these pipes. Okay, see from hot fluid we get the conversion 1 by hi what is the and for tube you have to answer thickness, that means wall resistance should be there, and get the cold fluid conversion in the cold fluid 1 by HOAO. That's all, simply add. Suppose the pipe is very small thickness and the material is very highly conductive, then you have to neglect the wall thickness. So you just we have 1 by HI plus 1 by H naught because A will be thickness is small means AI is equal to AI naught, that will be placed. Okay, this formula is more important. 1 by U is equal to what 1 by HI plus 1 by H naught. Okay, and we can solve a sum on this. Okay, see, hot oil is to be cooled in a double pipe, the double tube counterflow heat exchanger. That means double tube means what? Two pipes will be there. What is the flow? Counterflow means what? It will flow in the opposite directions. Two fluids will happen. Okay, heat exchanger. The copper tube, the copper inner tube. That means the inner tube is a copper tube and it's a diameter of what? 2 centimeter. Okay, and it is what negligible thickness. That means we can neglect the wall the resistance. Correct. The inner diameter of the outer tube. Okay, inner diameter of outer tube is what? Is 3 centimeter. Either the in outer tube or shell. That is what is called 3 centimeter. Okay, that means they have two tubes. One tube is the inner tube of inner diameter 2 centimeter, over which another tube is there. It having a diameter of 3 centimeter, and that is the outer tube. Okay, and water flows through the tube at a rate of 0.5 second, and oil flows through the shell. That means oil is flowing in the outer shell at a rate of 0.8 second. Okay, water is flowing in the inner tube and oil is flowing at the outer tube. Taking the average temperatures of the water and oil to be 45 degrees Celsius and 80 degrees. That means average temperature means just suppose say cold water is flowing in the inner tube. Here inner temperature will be there, outer temperature will be there. They average the inside and outer temperature and then put divided by 2. That's what. For water is 45, for oil is 80. That is inlet plus the outlet divided by 2 for oil is for the 80 degrees. This is the average temperature they put. Okay, and what they asked to find the is the find the overall heat transfer coefficient of this heat exchanger. Okay, that means you must remember that formula. Yes, 1 by U is equal to what? 1 by HI plus 1 by H naught. Okay, you have to find this U value. Okay, because OH is formula means because OH was negligible thickness, so I can neglect this resistance, and is what since thickness is very low, that AI is equal to A naught. So automatically 1 by U is equal to 1 by HI plus H naught. That means I have to estimate only the heat transfer, convert heat transfer coefficient in the inner tube and convert heat transfer coefficient in the outer tube. Okay, for that how I can solve? We can solve some basics using the knowledge we have on convection. Okay. First, in any sum, first you draw the diagram. Diagram is more important. Mark all the dimensions and which side whole fluid is flowing and which side hot fluid is flowing. You must mark that. Okay. And followed by that, you have to estimate the properties of this fluid. Like for oil and water, you take the necessary properties from the data book, data book, and you put it here. Okay, and write it down. Okay. And now I have to find HI. How I can find HI? HI is related to how I can find HI can find from the asset number. Asset number is equal to what? H for the for pipe HT by okay. Okay, since this inner tube I put inner diameter. Okay, from if I form if I because DI I can find KF I can connective fluid from data book I can find DI. I know the inner dia is like 2 centimeter. You put it 0.02 meter. Only if I know asset number I can find H. Well, how I can find asset number? Asset number is related to what? Some constant It is a Reynolds number power m into Prandtl number power n. This is general formula for force conversion. Just there will be correlations will be available in the data book. You go to converse heat transfer, in that you go to force conversion, and you go to flow through pipes, because this fluid is flowing through the pipe. Go there. Okay, for that Prandtl number you can find from you can find from the data book, you can find, because the properties you have written. Okay, only if you know Reynolds number, so okay, we are done. Okay, how we find Reynolds number? This is a formula. Reynolds number is equal to what? Reynolds number is equal to u, which is velocity, u d diameter dia, by nu. Nu is what? Kinematic viscosity. Okay, in meter square per second. Just to put it, you will find in RE. But for that we have to find u. They are given the flow rate. They are given. How is flow rate? Flow rate driven velocity. M dot is equal to rho a v. Okay, in that m dot they are given for water, they are given, and rho is density of water, we know. Area is water, inner dia of the inner constant area of the inner tube. From that you can find v. Yeah, so this is only they have done here, correct? They are finding velocity of the water inner tube. It is going on. They are found to be 1.161. Just put in the Reynolds formula, you find this means number they find. And if you see the data book, the Reynolds number is greater than 4,000. That means it is a turbulent flow. Okay, for pipe less than 4,000 means it's turbulent flow, and we have to use the correlation called the tightest board-like correlation. 0. This is more important. See, same. This is related to this one, correct? What are the both are related? See, instead of it is 0.023. Reynolds number is there. For something point it is there. For heating it's point for cooling means what? 0.3. Okay, just put it here. Okay, yes, water is getting heated up. Okay, just put it here, and what you will get? You will get some number called the Nusselt number value you get. From that you can find the H value using the formula what I written here. Okay, just put you will get the H value. Again, this H is over. Same thing if you put the oil which is flowing outside. Same the properties you put here, and same, but the major thing you have to put in diameter, because you cannot use DO, you cannot use, because if you see here the water is flowing in the inner tube, so you can, we are finding you are putting DI, but the water is flowing in the outer tube, and which diameter means what? This is D outer, this is D inner, but water is flowing only in this space. So what is that? The actual hydraulic diameter was D outer minus DA. Okay, that's the, this only DA outer minus DA. The flowing in the area diameter is flowing only we have to take D outer minus DA. Okay, that's the diameter. Similar thing you put m dot rho A. See, you put it here, you get the velocity. So they just put the Reynolds number formula, you put it. See, here also it is less than this. So then is what? It is like a laminar flow. Laminar flow correlations will be there. Okay, and from that correlations we can find in the data book, you can find the value to be 5.45. Okay, and in this you can find H naught. Just substitute here what is, you don't get confused by this. 1 by u is equal to, you remember this one, 1 by u is equal to 1 by HA plus 1 by H naught. Okay, just put the HA value and H naught value, you will get some value here. Just take the inverse of it, you will get u value. Okay, this is what 74.5 watt per meter square degrees Celsius. This is the sum. This is more important. You don't forget. You please listen carefully and go through this sum once again, and again. It is more important. Use your data book and compare the formulas with your data book. Okay. For turbulence, we will have tightest board equation. For this laminar, we will have some correlation using data book only. Just to go through that. Okay. Don't get confused about anything. Okay. You better see everything. The sums known by important. This is a more important standard sum. Every sum what we are discussing in this chapter is like more practical. It is based on industry data, so you have to be very careful in using this. It will be easy for your future career also. And the book I am referring here is for heat exchanger is mainly heat transfer, a practical approach by Professor Sengel. Okay, it's a more important and very practical book. So I want you to download a soft copy of that. It will be available easily in the website. Just download that and use this one, or you can buy it for in shops also. You can buy very easy, cheap relatively. It's very standard book, very practical sums. Okay, so that you can get more knowledge in that. So I want you to, all of you, to solve these sums in your hand itself. Okay, your just major thing is that first you write the given, then you draw the diagrams, then write the property values, and then solve the sum. Okay, everything you please listen carefully.